Okay, let's get started. Hello, everyone. Welcome to today's TDengine webinar. My name is Jim. I'm the VP of Product for TDengine. And joining with me, we have Arun. Arun is one of our solutions architect. We're both based in the San Francisco Bay Area. So thank you, everyone, for joining. And so from today, we're going to launch a new webinar series called Industrial Data Management with TDengine. And this, as you all know, we launched a new product called TDengine IDMP, Industrial Data Management Platform. So this webinar series is designed to give you an educational series of webinars to show you how to apply TDengine time series database and industrial data platform under different scenarios. And the first topic for today's webinar, we're going to have the scenario where you're going to be ingesting data from MQTT into TDengine. And then Arun will show you how you can use IDMP's AI feature to build some of the dashboards, panels, and real-time analytics. So how do we leverage the power of large language model in the real kind of industrial scenario, okay? So, and here's a brief agenda for today's webinar. So we're going to start. I'm going to give you an overview of our product portfolio and where we are, and then Arun is going to dive into the webinar that we have prepared for you. And at the end of the session, there will be a Q&A session. So if you have any questions regarding the webinar today or the product itself, please use either the chat window or Q&A window to ask your questions. We'll try to get them either answered during the session or after the webinar. Okay. All right, let's get started with the introduction section. And let me share my screen with you. Awesome. So as you can see, the best place to get the information from TDengine is our website. So just tdengine.com, type that in. So for the products, we have two products right now. One is our TDengine time series database called TSDB. So this product has been on the market for 8 years. So we invented this product starting from 2017. It's been widely accepted and widely very popular among the industry. We have an open source of that as well. It's been downloaded by more than 800,000 people across 70 countries. And we have also over 500 commercial customers using our time series database on a daily basis. Some of the big logos you can see bottom here on the website. So that's our time series database. We have a new product called TDengine IDMP. It's an AI native industrial data management platform. And we introduced that at the end of July. So how does these two products work together? So I'm going to show you a very brief diagram to show what is the relationship of those two products. Okay, so this is the overall product architectural diagram for TDengine. On the left-hand side, you can see this is what TDengine TSDB do. And on the right-hand side, this is what represents TDengine IDMP. So essentially, as you can imagine, on the very left side, these are the different industrial data sources, right? So your data can be coming from a SCADA system, DCS, PLC controllers, or another database. For example, if you have saved your data in your SQL database or MongoDB, or let's say another data historian like the Pi system, right? So first, TDengine has an enterprise connector that will allow you to get your data from different data sources into our time series database. So we support common industrial protocols like OPC UA, OPC DA, MQTT. We also support getting data directly from other databases, like if you have your data saved in a Microsoft SQL database, or if you have it saved in MongoDB, or even other time series databases like InfluxDB, we can treat that as data sources. We can connect with Kafka, Telegraph. We can all get data directly from these protocols directly into time series database. If you're using the Pi system, we can also treat the Pi system, both the data archive and also the Pi asset framework, as data sources. So we can help you migrate the historical data from your other existing databases or data historians into TDengine. We can also treat that as a live stream data, right, into TD. So very comprehensive features for our enterprise connectors to help you get your data into TDengine. And once the data is in TDengine, we have a very high compression ratio. So we'll compress your data very well, at least a 10-to-1 compression ratio, usually much more than that, depending on the data pattern itself. And we can also enable very fast query of the data itself once it's in TDengine. And so this is our time series database. And on top of that, we built our latest product, which is the industrial data management platform. And with that, we enable you to add a lot of contextualization to your data. So for example, for the device itself or for the metric itself, you can add different attributes, or even the information about the device itself, like the user manual. If it's a PDF, you can import that into our IDMP platform. So that gives you additional metadata on top of that time series data that you saved in your time series database. Okay, and with that additional metadata and the semantics, it essentially makes this data AI ready. So the AI can understand, for example, what is the relationship of different elements within your tree structure, and how is the different metrics working together. What is the meaning of those metrics? What is the upper limit, lower limits? And with that understanding, another very awesome feature we're incorporating is essentially we're building an AI agent. So we're enabling large language models like ChatGPT or DeepSeek to read into your data structure, the attributes, the metrics, understanding the semantics, and based on that, they will give you recommendations as to what kind of panels might be interesting to you. So if they read into your database, if they read into your tree structure, they understand that you are managing like an oil and gas facility or several renewable plants, they will give you some recommendations saying, these are probably, you want to probably look at the maximum oil gas volume produced every day for the past 7 days, things like that. Arun will give you a detailed demo into that. So that is based on AI's understanding for what you need. They will give you recommendations, okay? And they also will give you recommendations as to what kind of analysis you will require to properly manage and run your operation. And there's also things like the events, what kind of events that you will need to generate. You can all do that configuration within the IDMP platform. So that's a brief overview of our product portfolio and how these different products work together. And let's go back to our slides. So without further ado, I'm going to turn it over to Arun, and I will remove my desktop from the stream.
Hey everyone, super excited to kind of dive in here with you guys. Really quick, before we get started, we are going over an example scenario today. So we'll be going over a electric vehicle monitoring scenario. And what we're going to do is we're going to take sensor data from these electric vehicles and we're going to send it to an MQTT broker, which TDengine TSDB is going to subscribe to. So what do you need to get started? It's pretty simple. You'd need Docker. For those of you who are using GUI interfaces, which I assume is 99% of people, you're going to want to install Docker Desktop. And if you have Linux, you can just install Docker. You're also going to need Git to actually download the repository from GitHub. But once you've got those two things, which I'm going to assume you have, then you're going to get started. So first, clone your repository. I've already done that. And then we're going to find the file labeled electric vehicle. So once you get into the file labeled electric vehicle, you just start up your Docker file. And I'm going to do that right now live for you guys to kind of show you how that goes. When you actually do it correct, you should see all of these images starting. And once they say healthy and started, you should be good to go to access your Docker image endpoints. For TSDB, the link is right here, and IDMP has a link right here. There's a couple things that could happen when you're actually doing this. So when you try to start it and it says port in use, more than likely you've already run a demo and an old demo is still up. If that issue still persists, you can actually look into Docker Desktop to make sure you have a clear view of like what images are running. So as you can see, that electric vehicle is started up right here. So I have a good view of those images and which images are running, and I can see what ports they're on to make sure that there's no conflicting ports. Okay, with that being said, let's dive into it. So we're going to go into the TSDB actually, because that's where we ingest the actual data. So once I refresh, I should see the TSDB is up and ready to go. Quick look into TSDB. It's divided into panels, and these different panels have different functionalities. The ones we're going to focus on today are the Explorer and Data In. For the Explorer tab, you're going to want to immediately create a database. So I've already done
And
that.
Arun, can you maximize the window, please?
Sure.
Thanks.
So I've already created my database, but if you haven't, you're going to hop in here, give it a name. So I'm going to call it evdata2. So once you're done, go ahead and just click create, and you should see it pop up. So right here, I have evdata2 popped up. Afterwards, you're going to pop in and create a data ingestion task. So for the data ingestion task today, obviously, we're going to get that sensor data, the MQTT data from your vehicle sensors. So the TDengine TSDB subscribes to the MQTT broker. And the way you can actually do that is import it. So we've already given you the data, and all you need to do is pull that from the MQTT broker. So when I click import task and I go into my IDMP folder, I should go into the examples and into electric vehicle, and then click on this evtask.json. Once you're there, you can go ahead and click your target database. So if mine was data2, I've already done it, so I'm not going to live run it for you guys. But once you've actually done it, you can click an import task, and that will start the process of subscribing TSDB to the MQTT broker. When that happens, you're going to see the status of the task. So this is one that I've already made. It's going to start saying it's going to go from queued to running. Once it goes to running, you can actually ingest the data with these commands. So once you see it go to running, I usually go in, copy this command, and I'll paste it right here into terminal. And usually another mistake people make is at this step, they think something is wrong. It's not. You just run the second command to send the actual simulated data. And as you could see, I'm publishing this data from my broker, and it's subscribing real time. So you can actually look at the data being subscribed to TSDB. Let's give it a couple seconds here. And I've already made this database, so I can show you exactly where this is made. So this is at Target EV, so this database right here, and you can actually go into it and see your data ingested. So if I go into this, I'm able to actually see the data, and there's a timestamp of it, so I can see exactly when it was made. For now, yep, my data has been ingested for today. And I can see it still being published. So once this is done, you'll be able to see that it's successfully published. So we're going to give it a couple more seconds here. But as you can see, TSDB allows you to see all the rows of data and tags. So for my EVs, I have the accelerator pedal, the air conditioning, the battery current, things like that. And as you can see, it shows you the amount of data that was published as well. Once the published data is ready to go, you can confirm it exists here. You can see the timestamp for our date. And now I know that my data is ready to go. We can actually use this data in IDMP. As Jim was talking about, IDMP is built on top of TSDB. So TSDB is the backbone of IDMP, but IDMP is where the magic happens. So I'm going to bring you guys to IDMP. If you go back to this page, you'll be able to see that we've provided two different links for you. The second link is, okay, I'm going up too high. The second link is the IDMP endpoint. So this one right here. And I'm going to go ahead and start it. When you get into IDMP, you should be able to see a tree-like structure. So on the left is the elements panel. Within the elements, this is a tree-like structure. So each of these inherit from the rest of them. And as you go deeper, you'll see your individual elements. So how can I actually import the data from TSDB into IDMP? Well, as I mentioned, IDMP is the backbone of TSDB. To actually import the data, it's pretty simple. So you go into your admin console and you look at connections. In the connections, you can actually set whatever LLM you want to. For instance, I'm using OpenAI right now, but you're able to actually change your LLM provider based on endpoint and API key. So if you have some kind of endpoint that like you want to use locally or locally hosted, or you want to use a different LLM besides ChatGPT, you can totally do that. For now, let's try getting the data in. So you're going to look for the connection labeled TDengine. And then once you find the TDengine connection, you're actually going to go over here and click Easy Import. Easy Import is how you bring that data directly from TSDB into IDMP. Right here, you're going to find the database that you want to import. So for me, it would be EV. I've already built this, but I could rebuild it if I wanted to. But if it was EV, like I said, I would click rebuild, right? And if I clicked rebuild, this data has already been processed for me, but it won't look the same for you guys, but this will. You would click the tables that you want to process. So I don't want to process every single data source. So for example, I don't want to process the sample data. So I'm going to click ignore. I'm going to keep going through all the super tables and click ignore until I only process the data I want to. Another thing is we follow that tree structure. So we have to give the tree a path and then the attributes that inherit off that. So for me, I picked car location and the other attributes to follow that location. As you can see, it'll be shown how that hierarchy looks when I actually go into it. But for now, I'm pretty satisfied. So let's go into see how exactly you can use this data to make incredible analyses. So I'm going to hit discard because I don't need to actually upload the data. But when I go to car location, you could see you have a couple different options, right? So I'm going to start with panels first. Panels are IDMP's magic. It's how you can visualize your data. To start out with, there are 3 different ways you can make panels, right? So the first way being actually looking at the AI suggestions. For instance, the top 5 vehicles by environment temperature. If I like this panel, I can like it, and the next suggestions I get will be more related to this panel. But for some reason, I don't like these panels, so maybe I'll dislike it. A new suggestion will pop up. If you see all these suggestions and you think they're kind of old and you want a different suggestion, you can also click more suggestions. But there's also another way I can like make panels, right? I don't have to just follow this. I can also just prompt the panel. So top 5 vehicles by temperature, right? And now I've just asked the AI to create it. So instead of clicking on suggestions, I just prompted it. And I forgive my spelling, but as you can see, top 5 vehicles by temperature, and it's actually labeled individual vehicles. So I could specify if I wanted it by brand or by individual vehicles. Again, you can also just create these panels, right? I can just make a panel. So I can make a panel. This is probably not the best example. So for a location doesn't really have properties other than the properties of each individual like vehicle. So better example to make a panel would be for individual vehicles where I can add these metrics, right? So these metrics are exact same as what you've seen in TSDB, but they're in IDMP. So you can make panels with these metrics, right? So for here, I've made one with the air conditioning power. That's how much power the air conditioner uses in a car. For metrics, you can also do predictions. So if I want to, I don't have the service available, but you could do predictions. So with different algorithms, I'll just show you the screen here. So you can do it with ARIMA. We have our own TSDB algorithm. There's multiple algorithms that you can do predictions with, and you can only do that on raw data. You cannot do predictions on generated data because of how TSDB is built, but you can do it on raw data. So just the raw metrics, you're able to run predictions. So I could see predictions on this data. So those are the 3 ways to make panels. I can kind of show you what good panels look like, because I've generated a couple for you guys. But yeah, these are some of the nicer panels that you can make, and you can take these panels and do a wonderful thing with them actually. So let's say I really like the New York panels, and we're going to give it a second to load here. I'm unsure why it hasn't loaded, but if I wanted to group these panels together in a way I could is more showcaseable, I would go to dashboards, right? So if I go to my dashboards, I can first of all see all the panels I have. So you can look at every single panel you've created. These are all the panels that I've made. It's an easy way to see like which panels you think look the best, which panels that you want to use. So for me, I want to make a dashboard. So I'm going to go into showcase, and this is one of the dashboards that I've already made from that panel set that you guys have already seen. But you can go in here and edit, and for your element, so mine was New York, you can drag your panels in. So if I want to put this minimum voltage in, I could. If I want to put the proportion of power in, I could also do that. And I can label these and move these around best as I can. So let's see. If I want to do it like this and drag one of these panels here, I could totally do that. I could also bring in panels from like my child elements and also create panels on the fly and insert them. So dashboards are a really powerful way to kind of present your panels in a visual way, instead of just seeing them on your dashboard or on your panel screen. So if I click save here, I can go back and I can actually see these panels. And it's a great way to showcase your panels in a visual way and a way to present them, right? So if you wanted to present this data to someone, this is the best way to do it. So that's dashboards. Let's look at another magical feature, because demos are nice and panels are nice, but one of the most powerful things about TDengine is how you can actually use these insights. That would be through analyses. So if you guys are familiar with the Pi system, one of the best things you could do with your data is actually alert people before something bad happens, right? So some of the ways you could do that is to create analyses. And just like how you make panels, analyses are made in 3 different ways. So similarly, I have the suggestion way. So with AI has generated these suggestions for me. So you could calculate the average battery voltage of the past hour every 10 minutes. You could calculate the maximum drive power. So if I like this one, again, I can like it. If I don't like this one, for instance, minimum stock of the vehicle every 15 minutes, I don't think that's that useful. Go ahead. So that's one of the ways. You could also just prompt it, like I've shown you before. If I wanted to, I could type something out. So let's say I don't like this one, and I'm going through this. I want the environment temperature every 15 minutes. I don't want it every 10. It's going to go ahead and take our agent and generate the analysis, just like how we made panels. So if you give it a couple seconds here, and again, it allows you to kind of customize it however you want. But when you do an AI generated one, it's already tagged for you. So you can actually see it being tagged. There's multiple trigger types. For us, it's that 15-minute trigger on the electric vehicle template. So if you want to change the template, you can. And again, very similar to how regular industrial systems work, you can go ahead and click save on that. And it's already ready to go. It's already ready to start. If I wanted to, I can convert this to a template actually. So this could be saved across the tree structure. So I could see it around, and I could use these analyses to create events, right? So events are how you're going to alert people. So based on this, I can make an event template, and I can make an AI event template. And so if it passes a certain temperature threshold, which I can adjust in the settings, I could get a notification to myself. So for instance, if I click this send notification button and I go to my email, I can get an alert for this. Sorry, give me a sec. Let's give it a couple seconds here. It might have gone to my spam. Maybe not. Okay, so normally the event would pop up. I'm unsure what's going on there, but you can actually see the event pop up. You're also able to see an analysis of the event. So you're able to see a real-time analysis of that event. And it's just another way for you to use this data in any particular way. So again, there's 3 different ways to make these analyses. You can, one, create a AI generated event analysis. You could prompt an analysis, or you could make it manually if you wanted to, right? So those are some of the ways you can manipulate data. What if you needed information about this data, right? That's where our AI chat would come in. And it's not just data information. Our agent gives you information about everything, right? So I can ask it TDengine specific data. It would give me data, and it uses context on all of this data. So you are already able to see exactly what the differences are in with your data. Also, like if you're looking for insights and stuff like that, you could do that all right here, right? And we are model agnostic, which means we aren't dependent on one LLM or the other. So you can connect whatever LLM you want, whichever endpoint you want. So it could be a local LLM, it could be Claude, it could be ChatGPT, it could be DeepSeek, whichever LLM you're looking to connect, you're able to. And those are kind of the high level features of TDengine. If you are having trouble with this, most of the time it is a container issue. So most of the issues you'll run through most of the time are container issues. I would say the best way to diagnose these issues is looking through it manually through Docker Desktop, or you could actually look through your containers. So you could see all your running containers with this command, and you could confirm that your database has actually been made with these 2 commands. Those are the most frequent errors that we see. If nothing, you should restart Docker Desktop, right? That solves a lot of errors for a lot of people. And make sure that you actually close down your container, because a lot of the time people try to start the same image on the exact same place, which is never going to work. And if you wish to remove it by volume, you can run this command, but I recommend just using the regular Docker compose down. So overall, you've got 4 amazing benefits with the symbiosis of TSDB and IDMP. The first being that you have really easy data ingestion. You can automatically onboard this new data with super tables, and IDMP responds to you based on natural language. So it's zero query intelligence. So you can do this all with writing prompts or SQL queries. And if you just describe what you want, IDMP will make it. So it makes the barrier to entry really low. So you don't really need source knowledge. You just need to know how to prompt. And that's all from my side of things. Thank you guys for listening.
Cool. Thanks for the very interesting demo, Arun. And again, everyone, if you have any questions, just use the chat window or Q&A window to ask those. And we'll get a few questions. We already have a few questions coming in, so we'll get that started. So the first question we saw is, how can I get this demo? So I'm actually gonna give you a, I'm gonna show my screen again here. So again, so everything, if you need any information, just go to tdengine.com, our webpage. And for example, we have 2 products, right? There's TSDB and TDengine IDMP. And if you click on the IDMP, browse, hover over the IDMP, there are a list of options here. So you can see the pricing for that, tutorials, docs, cloud, downloads, and products. So if you want to try out, if you have your own data, if you want to try out and download the TDengine IDMP, you can go to docs here, okay? When you're in the documentation, you can go to the quick start guide here. And we recommend, you can either choose the TDengine Cloud. It's a free registration. Everyone can try that for free for 15 days. And same with Docker Compose version. If you want to install it on your local computer, this is something you can install and just to follow the steps. And if you want to, for example, let's say if you want to have access to the demo or tutorial today, we have another Docker Compose built just for that. If you hover over products and go to TDengine IDMP and tutorials here. And as you can see, we have 4 tutorials listed here. And this one, electric vehicle with MQTT, just click on that. And this is the one that Arun went through today. Okay, so just follow that step by step, exactly as what you see in the documentation. And yeah, you should be able to go through that with no problem. And you can always send us emails if you have any questions with that. Okay. So that is, let's see, that is the first question. And the second question is, you can see, how can I do prediction? So that's, Arun briefly showed you where you can activate that prediction or time series forecasting button. So I'll give you a quick sort of intro of where you can see that. So for any of the forecasting or anomaly detection, we have a feature called TDGPT. So TDGPT is an advanced analytics features. We did a webinar on this before within TDengine. So that essentially enables you to use either some of the built-in algorithms or the machine learning models that you built by yourself directly in TDengine to do things like anomaly detection or time series data forecasting. So these advanced analytics features, as long as you have your TDGPT loaded, for example, if you're using Docker version, and if you want to use TDGPT, just go to our products and getting started in the Docker. As you can see, when you deploy TDengine IDMP, from a Docker Compose perspective, there are two different ways for you to start that. If you don't want the one with the TDGPT, just use this minimum installation setup. If you want to have TDengine TDGPT, if you want to work with the time series forecasting or anomaly, you can just choose this second command. Okay, following this second command, you will also be running the TDGPT along with the other system in your Docker at the same time. And with that, you will be able to go into the system and do a number of, real-time kind of data forecasting or anomaly detection using some of our features embedded. Okay, so that is how you can essentially, that is what essentially TDGPT is and how you can enable or start TDGPT. It's part of the TDengine package, so it's not something additional that you have to purchase. But of course, if you have your own machine learning model, for example, you train your own data with you have your own machine learning model that you want to incorporate, since we also support PyTorch, you will also be able to directly import the model that you built by yourself into TDengine, and you can use that algorithm to do the time series forecasting as you are running that application. Okay. So that is the answer to that question. And we have another question asking about, does TDengine support semantics? So semantics essentially means, what does the data represent in real physical world, right? So the relationship of different elements in the real world. So the way how we do that is, I think you can still see my screen. So we use the model tree to provide you with the semantics. So for example, this is an oil and gas companies. They have multiple oil fields in different states. They have a few in Alaska, and even under the Alaska, there are multiple areas, and each area have multiple wells, right? So how is where does this well 14 belongs to? Where is what is the relationship of this well 40 and that well 14? That this is our way of interpreting the relationship between different elements and how we're enabling you to understand what is the hierarchy. How does different elements, like what is the hierarchical structure between different elements, between different regions, different locations, and this also how you will be able to make sense of what that represents in the physical world, like where this well 18 belongs to. You can even do like an AI chat. You can ask the AI, where is well. Let's actually do a live chat here. So let's say if you want to understand like well 14, right? I've never done this before, so let's give it a try. Never asked this particular question. So it will take some time, but eventually it will give you essentially the answer of, all these semantics are all these relationships between different elements and this hierarchical structure between elements and where they are located, who they belong to, These are all this is the way how we interpret or how we represent semantics in TDengine. And of course, what you can also do is that once you are in TDengine IDMP, there's also the attributes factor that you can bring up. So if you are interested, for example, to understand, there are different attributes that you can set within one element. And those attributes can be dynamic attributes. So these can be like gas volumes, can be different, of those, but they can also be, static elements, right? So you can use those static attributes to represent what like some of the attributes of this particular device. If you have, user manual PDF documents explaining how this device works, you can do that. You can include it. Or for example, for some of the attributes you want to set, like upper volume, lower volume, you can do that as well. If you click into that, you can do the change and edits, and you can add any kind of a limit configuration. What is the minimum value, target value, forecasting configuration. Do you want to use TDGBT to do forecasting, and additional features and properties as you want? Okay, so these are all the metadata and information that you can all include within TDengine and within IDMP. So this generation has been stopped. So let's ask how many.
Jim, Marlon had a question about what kind of hardware it requires to run this stuff.
Oh, okay. That's a good question. So we actually have we're actually building a calculator for you to calculate. So essentially we can give you a quick look at this is our actually pricing table. So the way how we calculate how many cores is needed is actually based on the number of tags that you require. So there are two factors that you will need to consider. First is how many tags that you have in the field. And second, what is the average sampling frequency of those tags? Let's say if you have 5,000 tags and your average sampling frequency is 1 Hertz, which means you have 1 data point per second on average for those 5,000 tags, then TDengine, we only need 1 core for you to process all these data from a TSDB time series database perspective. And if you have, let's say, here, 80,000 tags, but if your average sampling frequency is 0.1 Hertz, let's say on average you get data ingested once every 10 seconds, then essentially you can divide that 80,000 by 10. So every second, the number of data points you're ingesting is about 8,000. So 8,000, and you can look at this table. So you will probably need 2 cores to process that. So this is how you calculate how many cores you need to process the number of tags that you have in the field based on the number of tags and also the average sampling frequency of the tag. We're actually building something like an estimator. So later when you go to this particular page, you can actually click that and do just a quick estimation of how many cores you need. And yeah, that's usually, and if you have further questions, you can just send us an email and we can always help you do kind of an estimation as to what is the best hardware configuration that is suitable for your scenario. Okay, and cool. So Arun, do you have anything else to add from your side?
Yeah, I want to mention that the best way to
Mhm.
learn about us is actually getting started. I think
Mhm.
hopping in, setting it up. I promise you guys, especially if you're on a GUI interface, even faster for Linux actually, but on GUI interface it takes 10 minutes, 10 minutes to get running. Just play around
Great.
with it. You don't even have to ingest data. We have a ton of sample data too. So if you don't have the time to actually ingest MQTT data, you can just get started with sample data, and it's really fast and really easy to get going. We also have constant support 24/7. So around the clock, you can email me or Jim, and we will get an answer to you no matter what. So feel free to try. Please reach out with questions. We're always available. And thank you guys for tuning in today.
Fantastic. And you can always, we also have a Discord channel. So if you search TDengine on Discord, you will find us. Feel free to join that. We'll be monitoring that constantly and answer any questions that anyone has. Okay. So with that, that will be the end of today's webinar. So we will be hosting a weekly webinar from now on. If you're interested, stay tuned to our LinkedIn post and just go to our website, the webinar page, to sign up for the rest of the webinar if you're interested in more of these educational series. Okay. All right. Thank you everyone for participating. Thank you, Arun, for the very interesting demo. We'll see you guys again later. Have a great one, everyone.
Thank you
Bye.
so much, everyone. Bye-bye.
Bye.